Welcome to the viewers. We discuss today the idea of convergence in nonlinear space. At first we are going to the part of the definitions. And if we consider, let N and norm be a nonlinear space, or shortly abbreviated as NLS, then number 1, a sequence Xn in N is said to be converge to an element. If we say it as x0, that's belonging to n, if given epsilon greater than 0, there exists a positive integer, if we take it as m0, such that, and for n that's greater than equals to m0 or greater than whatever may be, which imply norm of xn minus x0 that will be less than epsilon. This is our definitions, and that can be shortly write as limit as, that is, it is analytical definitions, and technically we are writing limit as n tends to infinity, that xn must converges to x0, or alternatively we can write it as xn that will be converge to x0, xn tends to x0. This is our definitions, and these two definitions if we are setting, we are writing, and this definition follows if these things happen and that criteria satisfied, if and only if, that is norm of xn minus x0 also tending to 0. This is general definition, this is analytical definitions. And in the prospect of Cauchy, simply we are taking a sequence, we require a sequence. Which type of the sequence? That is taking as xn simply, no matter for that, and where the sequence in existence of the sequence in n. That is a nonlinear space. We are taking, if we are taking a nonlinear space n, we are taking the sequence xn there, and this sequence in nonlinear space is said to be Cauchy. That is the criteria of Cauchy sequence. Which type of criteria? If, first going to the analytical definition, given epsilon greater than 0 and there exists a positive integer m0, if we take, such that in the same criteria, that is m and n, if we take both m and n, that is greater than m0, which imply norm of xn minus xm that is less than epsilon. And this nonlinear space, another definitions we have, and if we take it number 3, a nonlinear space n is called complete. If we are taking as a complete sense, what happens there? If and only if every Cauchy sequence or CS, shortly abbreviated CS, in n is convergent, and if we are taking in convergence that sense, that is, for each CS or Cauchy sequence xn in n, then there exists, if we are taking existence of an element, if we say it as x0 in n, such that this xn must be tending to x0. So we fill up all the definitions which are very much useful in later sections of functional analysis. We end our discussions here. If you like this video, like it, share it, and always subscribe the channel. Thanks for watching.